All right, so on the pre-lab, here's what you're going to do. Hold the concave mirror at an arm's length so you can see your face. Is the image upright? You're going to go through some different things. And answering that. So here's the story. So you're going to have a concave mirror and you're going to have a convex mirror. What's the easiest way to tell the difference between the two?
Concave is upside down.
Yeah, so if I take this one and I hold it up, no matter what I do with it, I always see an upright image. So this is going to be convex. If I take this one and do that same thing, if I get it close, I get a big image, horrible pores. And then if I move it away, I get one that is upside down. So this is my concave. That's my convex. Okay, so do that. Write down what you see. Is it getting bigger? Is it getting smaller as you change that focal length? Okay, now the first part of this lab is relatively straightforward. So over here on page 2, okay, you've got this data table that you need to fill out. So you're going to set the object distance at being 100, 90, 80, 70, 60. Okay, so you're going to change this value. So the first object distance, you're going to have this, the camera or the 4 set at 100. And then you're going to have this set out here at 110. Okay? So remember, you're not starting these at 0. You need an object distance of 100. So I'm going to set this at 110, or this at 10, this at 110, so that the distance between these is 100. So I've got this adjustable mirror. So what's going to happen is the light is going to come through here. It's going to go through this open half screen. It's going to hit the mirror. It's going to bounce off of it. And then we're going to try and make that image show up here. So I adjust that position until I get that 4. Hold on. There we go. Now, what I would suggest that you do is that bring it close. If you're too close, you're out of focus. If you're too far away, you're out of focus. There's a sweet spot where that 4 just comes right into focus. So this distance from here to here is going to be what? No, that's not your focal length. This is your image distance. So the distance from the 4 to the mirror is this is the image distance. Okay? Now, what you're going to try and determine is the focal length. Okay? You're going to try and determine that focal length. But you're going to know psi and so. So if you know psi and so, how are you going to determine?
Add the inverses.
Yeah, so you have to calculate the focal length. Again, I don't want to see every calculation, but I want to see one calculation of that focal length. Now, you need the object height and the image height. Well, the object height is just going to be however big the 4 is here. That's not going to change, okay? That's a fixed value. You can either take a ruler, you might even take like a piece of paper and like put it on there and make a mark on a piece of paper and then measure the mark. You're also going to need the image distance. Now, that's going to be tougher to do because this is what you need to measure, is that tiny 4 that's on here. So what I would do, I would certainly, don't try and take a ruler and try and measure that. I would take like a piece of paper like this and line that up with the top and then make a mark on the paper and then measure that. That's going to be much easier than trying to get a ruler in here. Then you're going to calculate the magnification.
Do these have clamps so they don't move when you try to?
Yeah, they're somewhat held in place. Okay. Then you're going to calculate the magnification. I don't care how you calculate the magnification. You can use psi and so, high and ho, whatever, however you want to do it. But again, show me one complete set of calculations. Now, then you're going to change the object distance to 90. So I'm going to slide this from here. Then I'm going to move this to 100. Now this is 90 centimeters. Then I'm going to do the same thing. Now I'm going to make this come into focus. And then I'm going to be able to measure the new image distance here and the new image height. So basically, you're just going to keep bringing this thing closer and closer and closer until it comes into focus. And you're going to see what that trend is going to be. What's going to happen with your object distance, what's going to happen with your image distance, what's going to happen to that value, that magnification. Okay? So you're going to end up at 60 centimeters away, which means your final one is going to be, this is going to be at 70, and then you're going to have that 4 there. Boom, there you go. That's all the data that you have. That one's as simple as it gets. Now, the other one. Out of all the things that I will ever teach you, whether you've been in my Chem 1 class, my AP Physics 1, AP Physics 2, the next thing I'm going to try and explain to you is the hardest thing I can ever begin to try to teach you. Okay? Because I can't show it to you. So, over here, so come over here.
It's gonna be invisible.
So, here's the problem with the convex lens. So, here's going to be the setup for the convex lens. So, you need a half screen at 10. There's no light source. You just need a half screen here at 10. You need the convex mirror set at 55. So this is going to be like 40 centimeters, okay? Here to here. Oh, there you go. 45. 45. Now, here's the problem with convex mirrors. Convex mirrors only produce virtual images, okay? I can't project it onto a screen because whenever I look at this, it's going to look like it's on the other side. So with that one, it was easy. Oh, I could make that image and I could bring it to where it was in focus. Cool, great, because it was a real image and I could measure that and I could get it onto a screen. Convex mirrors are horrible because of the fact that I'm going to look at this, okay, and like I'm going to see myself, but how do I begin to measure like where I see myself on the other side? Because if I hold this up, I can see like all of you, but it was like, how do I begin to measure that? That's the toughest part. So here's what we're going to do. And you got to stay with me here. Just bear with me. So we're going to use something called parallax. Okay? So here's a simple way to do parallax. So parallax is the apparent shift of an object based upon a different perspective. So if you hold your thumb out in front of your nose, okay, and you close your left eye and look at your thumb just through your right eye, you're going to see it lined up with some point in the room, okay? Now, open up your left eye and close your right eye.
Bar get shifted.
What does your thumb appear to do?
Move.
Your thumb appeared to move. Did it actually move?
Yes.
Oh.
No.
Yeah.
Now, do it with the thumb further out. Do the same thing.
Oh my gosh.
Does
if
it
it's
move
closer,
more or
it's
less
farther
as
away.
it goes further away?
Less.
Moves less. So when you're up close, the apparent shift is much bigger.
Why do you do that?
Now,
It's
we actually do that in the distances to stars because if you imagine like here's the sun, here's the earth, and here's the sun, here's the earth, and you're looking at a star. 6 months later, the earth is over here. And then you're looking at the star that way. And so the farther the star is, the less that it shifts. And the closer it is, the more that it shifts against that background. Okay? So we're going to do a similar type of thing with this. Okay, now this is what I'm going to tell you is the hardest thing for me to explain. Because I can't show it to you. Okay, but I'm going to kind of show you what you want to try and do. So, you got to get down here like this, which is hard on an old man. And what you're going to have is you're going to have your convex mirror here, and you're going to have a screen here, and then you're going to have this line. Okay? Now, this is what, I have to explain it, but I can't show you because you can't see through my eye. But what you need to do is look here, and you're going to look, and you're going to see, as you look, you got to be up above. So you're going to see the line here, and you're also going to see this half image in the mirror. Okay? So you're up above, you're looking down, you're seeing this line here, which is this, and at the same time, you're seeing this line back here. Okay? Now, what you want to do is start with this really close. So if you do this, this is where you're going to get into this parallax. So if you move your head, like if I'm moving my head, what you're going to see is that as I move my head, you're going to see this line. I'm going to move my head like to the right, but I'm going to see this line relative to that split screen move to the left. Okay? So if I move my head this way, I see this move in the opposite direction of this. If I go the other way and I move my head to the left, it looks like that is moving in the opposite direction. So if I go back and forth, the direction that I move my head, this appears to shift. Now, if I move that back a little bit, okay, so this is like moving your hand further away, okay? So if I move my head back a little bit, what you'll see is that that relative motion becomes a little bit less. If I'm just at the right spot, okay, and this is why I said I cannot show you this, I can just describe it. So when you get this at just that right spot, when you move your head, this line doesn't appear to move relative to the screen. Okay? Just stay with me.
Cool.
Now, if I go too far away, like that, then when I try and do that, I'm back to having parallax, but then the shifts occur in the same direction. And some people get this and they see it. Other people, it's just like, oh my God, I have no idea what you're talking about. Elliot?
This line to what?
I'm comparing this line here to the half line image that I see in the mirror. Okay? So I'm comparing this to what I see in the mirror. Okay? So this line to this line. Now, let me give you a hint. When you get this, it should be something around 14 centimeters. Okay? It's a ballpark. Okay? Yeah, because literally, I mean, so, but here's why this is tough, is that I'm sitting here trying to explain to you two images that I'm looking at, and they're moving relative to each other, which is tough to do. Okay? So, and if you have it really close, that's when it's really easy to see. So what you're looking at, you're up above looking down like this. And you're comparing the image that you see in the mirror to that screen, to that line up there. And if I move my head one way, that appears to move in the opposite direction. So when it's up close, that's easy to see. You can easily see that. The tricky part is that how do you determine when that parallax shift goes to zero? Okay? But the farther back you go, it becomes less noticeable. Olivia.
Can you explain, like, why exactly does it go to zero, though? Like, why is it that you don't seem to see it, like, move?
Because what's going to happen is just like, imagine that you put your thumb far enough out relative to your eyes. If you're far enough out, that shift is going to become like so small. And that's what's happening here, okay? Because you're not closing your eyes, but you're moving your head. And that's going, so the movement of your head is what's creating the shift instead of closing and opening your eyes. Okay? So that's why I said, out of everything I ever tried to teach you, this is the most difficult to explain. Because I can't show you what it looks like. Okay? But what you'll see, like I said, if you start this really close, you can easily see that shift in that parallax because you're going to see this image here in the mirror move in the opposite direction that is. Okay, so you can easily see it when it's up close. The sketchy part is what happens when it gets further away. Okay? Got that. All right, stop you on the camera. Let's go back up there